lovers. Welcome to notes number 44, more of lesson 2.3. Couple things we want to go over with you today. We're going to talk about rate of change. We're going to talk about even and odd functions, and we're going to start with a zero question. So number 59 from your book, they ask us to talk about using the graphing utility, okay? I'm not going to use the graphing utility. I want you to use your brain, okay? So think about this graph. They want us to find the what the graph looks like. So I'm going to start with the zero. So let's set this equal to 0. Set this equal to 0. And we're going to go ahead and factor. I don't know about you, but this minus in the front, that's bothering me. So let's going to factor that, make this negative 3x squared, make this plus 2, okay? So now I've got, let's see, a negative 1 out front. I can factor that, no problem. X minus 2 times the quantity x minus 1. So my graph is going to touch, let's see, if x is equal to 2 and x is equal to 1. So if I'm thinking about what my graph is going to look like, x is equal to 2, that's going to be right here, and x is equal to 1. Uh-oh, I didn't really give it a good scale, did I? Now, I know it's an x squared, so it's going to be a parabola, all right? That x squared tells me it's a parabola. This minus sign in front, a being negative, is going to tell me it's going to go down, so it's going to go just like this. And my vertex of the parabola right up here is going to be halfway between 1 and 2, so this ordered pair up here is going to be 3 halves. And then I can figure out my y-coordinate by plugging this back in. So I could just put, f of 3 halves. Or if you guys like your decimals, you could go ahead and do that. Negative, well, we can do 1.5 squared, right? Square it plus 3 times 1.5. And then minus 2, you can do that. And that's going to give you 1/4. Which I like is 1/4. Okay, so that's just a quick little one. The other thing I want to talk to you about is rate of change. Okay, so up here with rate of change, average rate of change is you're changing your y value over you're changing your x value. So since we're talking about functions, we're going to use f of x2 minus f of x1. So the difference between your y's and over the difference of x's. Does this look like any formula you've seen before? Yeah, slope, okay? So I'm going to give you the function here, f of x is equal to the opposite of the square root of x minus 2 plus 5. I'm going to give you your x1 is 3 and your x2 is 11. I'm not giving you your y1 and I'm not giving you your y2. That's something you're going to have to figure out. Once we figure that out, then we can plug it into the formula to do the average rate of change like the directions for 81 says. Okay, so let's plug 3 in. Let's find f of 3. That's equal to the opposite of the square root of 3 minus 2 plus 5. So 3 minus 2, that gives me 1. So I've got the, let's see, make it neat, negative square root of 1 plus 5. So that's negative 1 plus 5. That gives me 4. So I'll put my 4 in here. And f of 11, let's plug 11 in, opposite of the square root 11 minus 2 plus 5. 11 minus 2, that's going to give me 9. So I've got the opposite of the square root of 9 plus 5. That'll be negative 3 plus 5, which gives me 2. So I'll put the 2 up here, okay? So now I'm ready to go ahead and use my formula. So my formula says f of x2 minus f of x1 over x of 2 minus x of 1. So f of x2, that would be, oh my gosh, look at me. Oh, I'm not even using function notation here. Oh my goodness, what kind of example am I setting here? So sorry about that, friends. So that should be 11 minus 3 over, goodness gracious. No, I have that backwards again. I'm all flustered now. That should be 2 minus 4 over 11 minus 3. That's much better. So that would give me negative 2 over 8, which would be negative 1/4. Okay, good. Oh, sorry about that. 2 mistakes. we should be consistent. We should use function notation as we go through. All right. The last thing I want to talk to you about are even and odd functions. And I want to do it graphically, okay? Even and odd. Oops, 1D. Oh my goodness, all these mistakes. Must be time for me to take a break. Okay. So an even function is one that is symmetric over the origin. I'm sorry, no, over the origin, over the y-axis. Definitely time to take a break. Whew. Okay, symmetric over the y-axis. So that would be a graph that looks like this, okay? An odd function is going to be symmetric over the origin. So that would be a graph that's going to be like this. So it's reflected over the y and reflected over the x. So it's two ways. All right. So I don't make any more mistakes, let me give you some notes on even and odd functions. So what we're going to go ahead and do is to determine if I have an even or an odd function. Let me see if I can zoom in a little bit better on this one. Okay, that's a little bit better. I have an even function if I have f of x and I replace x with the opposite of x and it stays exactly the same. There's no change. So here's an example. F of x is equal to 3x squared plus 4. If I put the opposite of x in, I'm going to have absolutely no change. It's going to stay exactly the same. That's called an even function. All right, it's symmetric over the y. An odd function is one where I replace the x with the opposite of x, and the whole thing is totally opposite. Okay, so that would be like the one we were talking about just right here, where everything in the first quadrant flips to the third quadrant because it becomes negative. All my positives become negative. All my positive x's become negative. All my positive y's become negative. So if I have the opposite of x and I plug it in for x in both spots here in this example, do you notice how the whole thing has changed and it's become odd? Now, not every function is even or odd. There are lots and lots of functions that would be neither. So I had this example ready for you, 3x squared plus 2x. If I replace x with the opposite of x, do you notice how one term changes and the other term does not? 3x squared doesn't change at all. So this would be neither. The majority of the functions you're going to work with are going to be, neither, okay? But even and odds are the big ones, okay? I'm going to go take a break. You guys have a good afternoon. Enjoy your problem set.